I think we heard a lot today about how AI again has been instrumental in making things faster, newer things that were not possible before. But I want to shift attention to a place where AI is actually being used to make something that already exists more accessible to a lot of people. And to talk exactly about that, we have our next speaker, product designer from Microsoft, Sabhyata Jain.
Okay, hello, hi everyone. I'm Sabhyata, I'm a product designer at Microsoft. And I know a lot of people in the room were talking about, how data visualization makes the invisible visible. But for a lot of people, that medium itself remains invisible, right? A lot of work that I do is in human-computer interaction and how people sort of find novel ways to interact with their PC. And one big part of work that we're doing is in accessibility in AI, especially focused on people with visual impairment. So people with visual impairment access their PCs using a device called screen readers. It's JAWS, NVIDIA's, narrator, and you'll hear something, and then we'll get to the next.
Ice cream sales by flavor. Jan, mango 6,000, chocolate 21,000, vanilla 24,000. Feb, mango 8,000, chocolate 35,000, vanilla 35,000. March, mango 12,000, chocolate 52,000.
And I don't need to repeat it, right? What you heard right now is basically this graph, right? If you take a minute, and you can figure out what are the larger trends, clusters, patterns that we're looking at. But what you heard just before this was a screen reader announcing each and every element. The cognitive load of figuring out patterns still lies on the user. They might as well just listen to an Excel sheet. And how do we make data viz accessible? There are tools that we have already. That means ensuring that your interactive experiences have a defined tabbing order. This basically establishes how the screen reader will move across the screen when the user changes focus. It also means making sure that your graph is accessible in high contrast when people switch modes. But of course, this is not enough. A lot of times, in spite of doing this, in spite of so much advocacy around this, a graph like this, a screen reader focus will come and the user will hear
graphic.
Yeah, that helps. So it's painful. And it's painful. People have failed exams because of that. And even when a database is extremely accessible, which is the audio that you heard in the beginning, it's like seeing the world through a microscope. You know each and every detail, but you do not know the higher picture. And so what we're navigating are these two key pain points. The responsibility of accessibility currently falls on designers and developers, right? And we cannot always hope that they get it right. And second, even if they do the job right, the most accessible visualization will still cause excessive amount of information fatigue to people with visual impairment. And so we asked, wow, the word. What we asked is, can we sort of take this burden away from designers and developers and make our screen readers accessible themselves with AI in a way that they could be the eyes. And so what we started was, we thought, oh my God, genius, we're gonna use AI and we're gonna just completely revolutionize the accessibility industry. And so we're gonna, each time a screen reader focus lands on the graph, we're gonna describe what it's talking about. And the users really humble you, because we were telling details like, oh, the x-axis represents this, the y-axis represents that, the yellow bar represents mango, the purple represents chocolate, and the users were like, I don't care. I don't care what is yellow, I don't care what is purple, what's on the x and y, you think you care, because you made it. I want to know the high-level insight. And so we realized we were using AI as a solution. What we needed was to use it as a tool. And so another food analogy, we sort of zoomed out and we were like, can we figure out why the data visualization exists in the first place and what is the role that it plays for people with vision? And so it lets you consume information in 3 layers. First is the outer layer, which gives you high-level context. Then is the middle layer that will give you key insights and clusters where you're deriving your insights from. And then that is the core, very specific details, right? And instead of just doing a flat application, can we let people with visual impairment also experience a graph through these layers itself? And so what we mean is, when users land on the visualization itself, we give a very high-level context, which can be very proactive because AI can predict that.
This chart shows monthly ice cream sales for mango, chocolate, and vanilla from January to June. Chocolate and vanilla grow steadily. Mango starts low, but rises sharply in April, overtaking the others.
And so this gives you high-level context. What you're looking at, it gets you started. And user might want to know more. And so this, the AI can elaborate.
In January to March, chocolate and vanilla dominate. Mango starts much lower, but rises sharply in April. In April, mango leaps ahead of both other flavors. By June, all three flavors cluster tightly around 80 to 100K units.
And now, while this gives you high-level patterns, insights, you can also have a very specific need. I want to know specifically about mango. I just want to know what happened in May. And this is something that AI cannot predict, right? So the user would have to provide us active input. In this case, they want to know what were the sales in March.
Mango was approximately 12,000 units. Chocolate was approximately 52,000 units. Vanilla was approximately 46,000 units.
Yeah, this was, a lot of experiences, a lot of design work that we do. Designers in the room will know they die in decks and pitches and they never see light of the day. We were actually able to launch this in the Copilot Plus PCs, and it's available for users to actually experience it. I truly believe to be a lover, you have to be a hater. So if you're a practitioner of your discipline, you need to critique it. What I mean by that, let's begin with the first critique of the very application of AI on dataviz. Your eyes have bias. And what I mean by that is, if I'm going to just dim the rest of the bar charts and highlight one of them, the AI is going to just focus on the mango. And so you need a way to somehow apply AI on the original raw data itself. Second is our skewed understanding of what dataviz is. Everything is dataviz. And what I mean by that is anything that's visualizing density. You look at a date picker on a Make My Trip website, you immediately know, oh, I'm going to book like 16 July. It seems to be cheaper. Someone using screen reader has no idea. They're going to listen to each and every detail, then do the mental math, and then figure out when to book that flight. And similarly, it extends to plane flights or even a meeting calendar. And last, trust in the system. While AI has made a long way, there is still a little more we need to go. The same graph hallucinated one time and thought that first mango bar actually was 20,000 units, right? So people really trust screen readers because they're tools. They're like your mouse, your keyboard, your monitor. They don't have a bias attached to them. And so you still need the models to come. And there's still a long way, but of course, technology is catching up to us. And so I know a lot of people are going to be like, why does this matter? Wow, great, accessibility. This has nothing to do with me. I don't work with blind people. I don't work with people with visual impairment. But I want us to think about this idea of turning graphs with the help of AI into an audio-based output for people for visual impairment can also be translated and extended to people for low data literacy. It's the same access problem. I don't know what this looks like. And there the problem is, I don't understand what this means. And so we're working, this is a little glimpse of an experiment that we're doing with Government of Karnataka as part of Build for Bharat fellowship. We have Veda here, so shout out to her, who's one of the fellows on this. We're taking a lot of data that Government of Karnataka is releasing, and they want to make it accessible to rural citizens at panchayat level. But often it just comes in form of PDFs and these heavy dashboards, and we were like, oh, we're going to make it a much more accessible visualization, but on top of that, we're going to layer it with audio.
ಈ ಅಂಕಿಅಂಶಗಳನ್ನು ನೋಡಿದರೆ ಸಂಗ್ರಹಿತ ಮೊತ್ತ ತುಂಬಾ ಕಡಿಮೆ ಇದ್ದು ಹೆಚ್ಚಿನ ಬೇಡಿಕೆ ಇನ್ನೂ ಬಾಕಿಯಾಗಿದೆ. ಈ ಗ್ರಾಫ್ ಬಡಲ್ಗಾಂವ್ನ ರಾಜಸ್ವ ಸಂಗ್ರಹಣೆ ಬಗ್ಗೆ ಇದೆ. ಒಟ್ಟು ಬೇಡಿಕೆ 7,90,800 ರೂಪಾಯಿಗಳ 68 ಪೈಸೆಗಳಾಗಿದ್ದು, ಇದರಲ್ಲಿ ಒಟ್ಟು ಬೇಡಿಕೆಯ ಸಂಗ್ರಹ 18,796 ರೂಪಾಯಿಗಳು ಮಾತ್ರವಾಗಿದೆ. ಉಳಿದಿದ್ದು ಒಟ್ಟು ಬ್ಯಾಲೆನ್ಸ್ 7,72,504 ರೂಪಾಯಿಗಳ 68 ಪೈಸೆಗಳು.
And so I want to end the talk with saying, when you design for the outlier, you design for everyone. And also being disabled is a minority. All of us will be one day. We all will be old. We all will be looking at our screens from this much distance. And we will all be tapping for it. So when you're designing for accessibility, you're essentially designing for everyone. Thank you. Pardon?
Like, let's say the output from the AI is a bit incorrect. So how does the users make sure that they don't get the wrong insights from that?
Yeah, so
Like,
that
how
is,
do you build the guardrails?
it is, we need better benchmarking. That is the only way. You need to push the industry to really focus on this. Because currently, VLMs, which is what we use, visual large models, they're still on the fringes, and they have their applications, but they don't often end up having that much focus. So you need to really push the industry to do it better. It cannot be on the user. You cannot expect user to do the job. The problem is the gap of accessibility is so wide right now. They are okay with anything, which is kind of problematic as well. And so while the application of technology is there is a need for you to push the industry. Slightly more complex models do a greater job at doing this analysis, but they tend to have a higher loading period. So users really need to have to wait. So if you're using O3, it's way accurate than 4.0. But that's a trade-off that one has to make. But one thing I've realized when I was pitching this ideas 2 years back, AI models were somewhere else. And people were like, oh, it's going to be inaccurate. Let's not do it. It's a really high risk. And I'm not kidding, within 6 months, they caught up. So the speed at which technology is evolving is way faster than we can think. So they will catch up eventually.
Hi, this side, on your right. Yeah, I have a question on, and just a bit more curious around the interpretation that is coming from the AI, because let's say when we are looking at charts and graphs, so there can be n number of interpretations, but maybe somebody is choosing probably one interpretation and the AI is choosing a single interpretation and offering it as the only solution or the only way to interpret that graph. Through an example, what if I wanted the most expensive ticket on the whatever the, so how do we solve for that?
Yeah, so there's the traditional way of accessing the screen reader as well, right? You could possibly hear entirely. What you're right, like, oh, what if I don't want to know about what's the cheapest size? So you create balance. One thing we were also trying to do when we were creating the models we weren't applying them flat. There's a lot of preempting and prompting optimization that was going into it to cut bias as much as possible, A lot of times it would come and tell, oh, I think this is what the insight was. And we were like, you cannot have that. And so it's a trial and error and making sure the AI is really optimized to give the right response. You cannot preempt it. You can only, and that's the reason, in the onion peel theory, you can only preempt context and high-level patterns, but you cannot preempt expectation and needs. Users would have to express them, and then the response will come, and we don't even want to design for it, because it's unfair to design for that.
That's all the time we have. Thank you, Sabhyata.